Today is 25th February 2026, and we have studied interference, diffraction, and now the last topic on light, it is polarization. Sir, what is polarization? Polarization means, sir, if we have decided that light is a wave, then wave are of two types. Wave is either transverse or longitudinal. So polarization of light, it is the phenomenon of light which provide evidence that light is transverse in nature. Light is not longitudinal, light is transverse. And polarization of light only take place in transverse wave. Polarization is not possible in longitudinal wave. ठीक, तो ये तो इसका इंट्रोडक्शन हो गया. अब नाउ वी आर गोइंग टू अंडरस्टैंड कि सर ये पोलराइजेशन है क्या, तो जरा समझिएगा. बात कुछ यूं है कि फॉर एग्जांपल इस डायरेक्शन में लाइट जा रही है, लाइट ट्रेवल कर रही है इस डायरेक्शन में, तो दिस इज द डायरेक्शन ऑफ ट्रैवलिंग ऑफ वेव. और जब हम ट्रांसवर्स वेव पढ़ाते हैं तो आपको याद होगा तो सर ट्रांसवर्स वेव में हम इस तरह की परपेंडिकुलर वाइब्रेशन करवा देते हैं. और ये जो परपेंडिकुलर वाइब्रेशन मैं ड्रॉ कर रहा हूँ, मेरे ख्याल में मैं वर्टिकल वाइब्रेशन ड्रॉ कर रहा हूँ. और वर्टिकल वाइब्रेशन को मैं इस तरह से भी ड्रॉ कर सकता हूँ कि these vertical arrows show that the vibration is vertical. लेकिन बड़ी इंटरेस्टिंग बात है कि लाइट में वर्टिकल वाइब्रेशन के अलावा सर हॉरिजॉन्टल वाइब्रेशन भी एक साथ हो रही होती है. यानी हॉरिजॉन्टल वाइब्रेशन भी हो रही होगी, वर्टिकल वाइब्रेशन भी हो रही होगी, और वेव जो ट्रैवल कर रही है सर वो इस डायरेक्शन में ट्रैवल कर रही है. तो ग्रीन एरो, इट इज द प्रोपेगेशन ऑफ लाइट वेव इस डायरेक्शन में जा रही है. और इस लाइट वेव के ऊपर सर दो तरह की वाइब्रेशन हो रही है. वन ऑफ देम इज वर्टिकल वाइब्रेशन, द अदर वन इज हॉरिजॉन्टल वाइब्रेशन. और हम लोग यूजुअली कह देते हैं इन दोनों में से किसी एक को कि ये इलेक्ट्रिक कंपोनेंट है और दूसरा मैग्नेटिक कंपोनेंट है. और हम कह सकते हैं कि लाइट वेव इलेक्ट्रो मैग्नेटिक वेव है. लाइट वेव इलेक्ट्रो मैग्नेटिक वेव है जिसके दो कंपोनेंट्स होते हैं, इलेक्ट्रिक कंपोनेंट और मैग्नेटिक कंपोनेंट. ठीक है सर, ये हमने आपकी इंफॉर्मेशन मान ली, लेकिन इस वाली बात को सर प्रूफ करके बताएं कि आपकी बात हम किस तरह एक्सेप्ट कर लें कि आपकी बात ऐसी है. क्योंकि याद रखिएगा लाइट को हम लाइट व्हेन लाइट वेव स्ट्राइक ऑन आवर आई, देन इट प्रोड्यूसेस सेंस ऑफ विजन. लेकिन ये पॉसिबल नहीं है कि आप लाइट को देखें कि लाइट इस तरह वाइब्रेशन करती हुई जा रही है. वाइब्रेशन ऑफ लाइट इज नॉट विजिबल. व्हेन लाइट स्ट्राइक ऑन आवर आई, देन इट प्रोड्यूसेस सेंस ऑफ विजन. लेकिन हम लाइट को देख नहीं सकते. तो हम जो भी बात कर रहे हैं ये सारी की सारी इमेजिनरी बातें कर रहे हैं कि लाइट जो है वो ग्रीन डायरेक्शन में जा रही है और इसके ऊपर दो तरह की वाइब्रेशन हो रही है. एक वर्टिकल इलेक्ट्रिक जो मैंने ब्लू कलर से ड्रॉ किया है, एक हॉरिजेंटल मैग्नेटिक जो मैंने रेड कलर से ड्रॉ किया है. दिस इज द ओरिजिनल लाइट. ठीक है जी. अब मैं इस वाली बात को समझाने की कोशिश करता हूँ. सर कैसे समझाएंगे, तो जरा सुनो. समझाने के लिए अगर बेटा मैं आपसे यूं कहूं कि कंसीडर आई हैव अ स्ट्रिंग. आई हैव अ स्ट्रिंग, मेरे पास एक रस्सी है. on this string is connected with a support. This is a support. ठीक है ना. And consider I have a cardboard. Consider this is a cardboard, and in this cardboard, sir, there is a vertical slit. There is a vertical slit, and this cardboard vertical slit and this string is passing through the vertical slit. अच्छा जी, अब मैंने किया ये कि this free end, consider it is in my hand, और मैंने अपने हाथ को वर्टिकल डायरेक्शन में जोर से अप एंड डाउन मूव कर दिया. When I move my hand in vertical direction, then vertical wave is produced, and when this vertical wave strike on the cardboard and cardboard having vertical slit, then this vertical oscillation easily pass through easily pass through the vertical slit. तो वर्टिकल स्लिट में से सर वर्टिकल वाइब्रेशन आराम से चली गई, हैविंग नो इशू. बट इफ आई टर्न this cardboard from vertical position to horizontal position, or consider I have another cardboard and the cardboard is again same shape, but now the cardboard is turned to horizontal position, and now the slit is horizontal. So when vertical vibration strike on the cardboard, then it cannot cross this horizontal slit. So there is no vibration beyond the cardboard. Sir, it shows that if the slit is vertical, vibration is vertical, then the wave can pass through vertical slit. But if you turn the cardboard and the cardboard is rotated at 90-degree angle and now the slit is horizontal, then vertical vibration cannot pass through a horizontal slit. So the same mechanism we can apply on light wave. And consider this is a light wave. And in this light wave, as I told you, sir, there are two types of vibration, vertical vibration as well as horizontal vibration. These are vertical vibration as well as, sir, there are horizontal vibration. And consider I have a sheet which is known in this topic as filter. मैं आपको YouTube की एक वीडियो से भी दिखाऊंगा फिल्टर किस तरह का होता है. जस्ट लाइक एक्सरे शीट, अगर आपने एक्सरे की शीट देखी हुई हो ब्लैक कलर की, उसी तरह का एक फिल्टर होता है. ठीक है ना. तो कंसीडर आई हैव अ फिल्टर एंड कंसीडर द फिल्टर शीट आई एम प्लेसिंग in the propagation of light waves, and consider the transmission axis of the filter is vertical. This is the transmission axis. It is just like slit. It is just like slit. So the transmission axis is vertical. So when light is incident on the filter, then obviously the vertical vibration, sir, vertical vibration easily pass through the transmission axis. It easily pass through the filter. But so the horizontal vibration, so the horizontal vibration, sir, cannot pass through this filter. And such a light is called polarized light. Right now it is vertically polarized light. Vertically means vertical component remain as it is, and it is called vertically polarized light. Its horizontal component is totally absorbed, and vertical component is passing through the transmission axis easily. Acha, watch this animation, if you watch this animation, it is just animation. Then, huh? In this animation, in this animation, you can see, sir, there are two components, green component and yellow components. And these two components is unpolarized light. But when it is passing through a filter, then you can see only one component is passing, the other component is absorbed. When the transmission axis is horizontal, You can see only yellow part is transmitted, and when the transmission axis is vertical, then green part is passing. And now there are two filters. There are two filters. It is important. आपके क्वेश्चन एग्जाम के दो फिल्टर वाले होंगे. When the second filter is rotated at 90 degree, then light is totally absorbed. When the second filter, when the second filter is horizontal, no light is passing. When the second filter is horizontal, no light is passing. Now the second filter is vertical, vertical component is passing. Yes, only right now vertical component passing, only vertical component passing. And when transmission axis rotated at 90 degree, then light is totally cut off. Then the light is totally cut off. So try to imagine क्या हो रहा है. And if you imagine good, तो obviously क्वेश्चन समझाना मेरे लिए आसान हो जाएंगे. The first filter is stopping yellow part and only leaving green part. It is called plane polarized light. And the second filter depends whether is it parallel or horizontal with the first filter. And now if we solve past paper question, then I think it is more clear. Now these are notes. In this notes you can see, sir, this is the direction of propagation of wave. Consider the light wave is propagating in this direction, and this is vertically polarized light. It means horizontal light is absorbed. And in another diagram, consider this is the light direction, and vertical component is absorbed, and only horizontal component remain. It is called horizontally polarized light. And now you can see these notes. And now I think it is better to explain. Consider this is original light produced by a source, and it contain multiple oscillation. We are dealing only two oscillation, vertical and horizontal, whereas this contain multiple oscillation. And when the light is passing through first filter, then you can see only the vertical components are passing and other components are absorbed. Then it is called vertically polarized light. And if the second filter is parallel with respect to transmission axis, this transmission axis is parallel. Parallel means the angle between the two transmission axes is 0 degree. Is if it is 0 degree, then the same light is passing through both filters. But when the second filter is rotated at 90 degree, you can see, sir, this is vertical transmission axis, this is horizontal transmission axis. Then both components are absorbed and no light is passing through the second filter. And now this is the first question which I am going to ask with Simra. Simra, beta, it is your past paper question. And now you can see, so this is the original light that it is called unpolarized light. And now this unpolarized light, obviously it contains horizontal, vertical, all possible oscillations will be there. But when it is passing through filter number one, and you can see the filter number one having transmission axis horizontal, whereas filter number two, I think they are at 90 degree angle. They are at 90 degree angle because their transmission axis is vertical. Okay. And now I am asking Simra, what is the right answer? A, B, C, D. Read question and tell me the answer. Light emerging from filter X. G. Unpolarized light oscillate in every direction. Unpolarized light. But when light passes through filter number one, then obviously it will oscillate in one direction. It will oscillate in vertical direction, sorry, in one direction. So option A and B are totally off, and option C and D, they are correct. Because when the light is passing through filter X, then oscillation in one direction. And when the light is emerging from filter Y, Simra, beta, are you in class? Simra, then I am asking you, when the light is passing through filter Y, and filter Y, you know, it is at 90-degree angle because its transmission axis is horizontal and its transmission axis is vertical. The angle between the two filter is 90-degree. Then when the light passes through filter number Y, then what will happen? It will oscillate in one direction or no light. Yes, it will be no light. So your answer is right. It means when the two filters are at 90-degree angle, then that light is totally cut off. And now the next question I am asking with Manahil. Manahil, beta, which of the following statement about wave is not correct? Actually, its first statement is also right, but we haven't studied. We haven't studied. Consider this is a glass block. This is a glass block, and when light is incident on the glass block, then you know light will exhibit reflection as well as refraction. And it is quite interesting. This reflected wave gets polarized. So when unpolarized light reflects from a surface, then it is also polarized. So this statement is correct. But as I haven't explained, so I should explain option A. Option A is correct. G, Manahil, now leave option A and tell me which is not correct. Option longitudinal waves cannot be polarized. Yes, it is also correct, but we are searching not correct. G. Option C, is it correct or not correct? I'm asking only this. If the light is unpolarized, then vibration in many directions. Yes, this is also correct. So first three options are correct. So the last option must be not correct. And transverse waves are always plane polarized. It is a nonsense because you know light is transverse wave, and according to this sentence, light wave is always plane polarized. It is nonsense. So not correct. So the right answer is B. Yeah, but when it passes through a filter, when light passes through a filter, then it is plane polarized. Otherwise, it is unpolarized light. Okay. And now the next question is very, very difficult. It is very difficult to explain. Gee, Zainab, can you answer this question? Very difficult to explain, especially for me. Okay. Actually, answer A and answer D. Actually, both often confuse students. And the difference is single plane and in one direction. It is very difficult to explain. So answer is either A or D. And I do not know कि आपको डिफरेंस पता है सिंगल प्लेन और वन डायरेक्शन का या नहीं क्योंकि अगर आप बाकी आंसर पढ़े तो इट इज सेम आंसर परपेंडिकुलर टू द डायरेक्शन ऑफ perpendicular to the direction of wave travel, perpendicular to the direction of wave travel. But the issue is, do you know the difference between single plane and in one direction? Do you know the difference? Acha, before taking your class, I was also confused because I think कि आंसर ए और डी में से मुझे डी पे ज्यादा लग रहा था सही, ठीक है ना? और फिर जब मैंने एमएस देखी ना तो डी ही सही है, ठीक, डी ही सही है. लेकिन द मेन थिंग टू एक्सप्लेन, सर व्हाट इज द डिफरेंस बिटवीन वन डायरेक्शन एंड सिंगल प्लेन? तो लेट मी एक्सप्लेन, ट्राई टू एक्सप्लेन बिकॉज वेरी डिफिकल्ट टू एक्सप्लेन. हाँ बेटा जैनब, मैं बताने जा रहा हूँ, ठीक है ना? आप अभी भी आंसर ए के साथ हैं बेटा जैनब, क्योंकि मुझे नहीं, मुझे पता है कि आपको वन डायरेक्शन और सिंगल प्लेन का मतलब नहीं पता है। ठीक है, तो आई एम ट्राइंग टू एक्सप्लेन। सर व्हाट इज द मीनिंग ऑफ प्लेन? व्हाट इज द मीनिंग ऑफ प्लेन? सो आई एम एक्सप्लेनिंग। Actually, you are taking class on a screen, and this screen having horizontal axis x axis, vertical axis y axis, and x axis and y axis, when they are combined, when it is two dimension, then this two dimensional screen, it is called single plane. It is called single plane. Single plane means horizontal and vertical both axes. Horizontal and vertical both axes. Okay, so single plane means, consider the wave is traveling in this direction. This is the direction of traveling of wave. And plane means there is horizontal direction as well as horizontal direction as well as vertical direction. And you can make a plane with horizontal and vertical direction. So single plane means a plane surface. डेली लाइफ में भी देखे ना, प्लेन सरफेस किसको बोलते हैं बेटा? प्लेन सरफेस में हमेशा कितनी डायमेंशन होती है? कोई सी भी प्लेन सरफेस ले लो, सिंगल प्लेन। सर सिंगल प्लेन हैविंग टू डायमेंशन। ठीक है, तो सिंगल प्लेन के अंदर हॉरिजॉन्टल और वर्टिकल दोनों एक्सिस मिलकर सिंगल प्लेन का टर्म बनाती है। वेयर एज वन डायरेक्शन, सर वन डायरेक्शन मीन ओनली वन डायरेक्शन। If the light is plane polarized, then there will be oscillation in one direction, and this one direction oscillation will be perpendicular to the direction of wave travel. जैना मुझे बताइए सिंगल प्लेन का मतलब क्या होता है? जी, बस बस बस, टू डायमेंशन, इट इज कॉल्ड सिंगल प्लेन। ओके, सो जी बेटा बोले। When light is unpolarized, when light is unpolarized, तो वो मल्टीपल प्लेन में वाइब्रेशन हो रही होती है, अनपोलराइज्ड लाइट। ठीक है, और जब वो पोलराइज्ड हो जाती है, तो polarized light after passing through a filter, there will be oscillation in one direction, not in a single plane. और देखिए जैनब, ये देखिए क्वेश्चन का एयर पड़ा हुआ है, क्वेश्चन नंबर पड़ा हुआ है। आप इसको एमएस में जाके देखिएगा। और पहले इस वाली बात, और मैंने आपसे कह रहा हूँ, मैंने क्लास से पहले बाकायदा चेक करा सिर्फ ये वाला सवाल, बाकी कोई सवाल चेक नहीं करा। ये वाला सवाल बेटा मैंने चेक करके बता रहा हूँ आंसर इसकी। ठीक है, तो अब आप समझ लें, सिंगल प्लेन मीन्स, सर देयर आर टू डायमेंशन एक्स एक्सिस एंड वाई एक्सिस, इट मेक्स सिंगल प्लेन। So when a light is plane polarized, then there is oscillation in only one direction, and which is perpendicular to the direction of wave travel. So the right answer is D. Zara, is it clear और कोई confusion है अभी भी? ठीक है बेटा। अच्छा जी, now the next question is very very simple. सिमरा जल्दी से आंसर कीजिए, बहुत आसान सवाल है। Which of the following statement about wave is correct? Simra, what is the Oh my God. Light. Oh my God. The light, light is a transverse wave, and transverse wave can be polarized only, and longitudinal waves can never be polarized. Okay, polarization is a phenomenon which take place only in transverse wave. Okay, so the right answer is D. And now the next question, Manahil, I am asking you this question. A ray of unpolarized light is incident on a polarizing filter. So it means this light is unpolarized. This light is unpolarized, and oscillation will be in multiple planes. Acha, is incident on a polarizing filter. The polarizing filter transmit light of intensity I as shown. Okay. The polarizing filter is then rotated in the direction shown on in the diagram. Okay, which of the following gives the intensity of transmitted light after the filter has been rotated 90 degrees? G Manahil. And remember, this is only a single filter. There is no second filter in this diagram. Only one filter we are rotating. Consider the slate. Consider this is the transmission axis. Okay. And I am repeating again, there is no second filter. Only one filter we are rotating. Oh my God. Transmitted light intensity is already I. And now it is not incident on a second filter. Only one filter is available. So if you are rotating the filter, there is no change in intensity. There is no change in intensity because we have no second filter. We have only one filter and we are turning the same filter. So obviously, when the filter is vertical right now, the vertical component will be passing, horizontal is stopping. And when you turn at 90 degree, then horizontal component will pass and vertical component will stop. So the intensity of the light will remain I. Okay. So the question is very, very simple. Okay. Okay. कोई बात नहीं. अच्छा बेटा, now we have a graph, and in this graph, there are two filters. Okay, in this graph, there are two filters. The when the light is incident on a filter and the light is polarized. When the light is polarized, and when the light is incident on the second filter, and if you turn the second filter at different angle. So when you are turning at 30 degree, 60 degree, 80 degree, 90 degree, and as I told you at 90 degree intensity will be zero for the second filter. For the second filter, I am repeating again and again. And now you are turning the filter further beyond 90 degree, then intensity starts to increase. And when the second filter becomes parallel with the first filter, then obviously intensity will again be maximum. And when the filter is further rotated at 270 degree, but for second filter, I am repeating again and again, for second filter, if the second filter is rotated at 90 degree, no light will pass. If the second filter is rotated at 270 degree, then no light will pass. And now we have a question from past paper. We have a question from a past paper. Read the question carefully. A student views a laptop screen through a polarizing filter. Okay. Student view laptop screen through polarizing filter. Initially, the screen appears normal brightness. He rotates the filter to 90 degree. At 90 degree, you can see at 90 degree, he observes the screen appears dark. It means the light emitted by screen is polarized. The light emitted from screen, it is polarized, and the student view this light by using a filter. Filter means it is second filter, and when the second filter is rotated at 90 degree, then no light pass through the second filter. Okay, and now the question is, explain what the student observed as he gradually rotates the filter to 180 degree and then to 270 degree. Sir, in the last graph we have already studied. Sir, at 90 degree no light, at 180 degree it will be maximum, at 270 degree it will be again zero. But read according to the marking scheme. Sir, at 180 degree the screen with normal brightness, because initially the screen appears normal brightness. So at 180 degree the filter is rotated at 180 degree, then the student view with normal brightness. And when oscillations are parallel to the filter, all the light is transmitted. All the light is transmitted. When oscillation is parallel, no light is absorbed. And these sentences are with or. Or means having same meaning. having same meaning. Okay, when the filter is rotated at 180-degree, the screen will be with normal brightness because the oscillations are parallel and no light is absorbed. No light is absorbed. So we have completed discussion at 180-degree. And now we are starting for 270-degree. At 270-degree, the screen is dark because 270 and 90-degree, no light pass. When oscillation are perpendicular to the filter, all the light is absorbed. Perpendicular, no light is transmitted. So it means it is repetition of same type of sentences. And now another question, June 2021. June 2021. The question is, explain the difference between unpolarized and plain polarized light. Plain polarized light. So I think you can write this answer yourself. And if you cannot write, then I will give you answer in my own writing. Otherwise, I am not interested to waste your time because the question is very simple. Sir, unpolarized light means when the oscillation in multiple direction and when oscillation only perpendicular to the propagation, then it is plain polarized light. So I think you can write. I think you can write. Otherwise, I will give you its answer. And now this is a question. So the question is, an unpolarized light is directed towards the screen. The intensity of radiation at the screen is 1 watt per meter square. Okay, so this is a light, and this light is incident on a filter, and this light is unpolarized. This is unpolarized light. And if it is unpolarized light, then obviously horizontal and vertical oscillation will be there. Two polarizing filters are placed between the light source and the screen, and initially the angle between the two filter is 0 degree. Is 0 degree. You know the light incident is at one intensity is one, and when the light is passing through the two filters, then obviously 50% of light will be absorbed by the filter and the 50% light will be transmitted. Consider this is the vertical vibration, this is the horizontal vibration. Then obviously only vertical vibration will pass. So I can say half of the intensity absorbed by the filters. And now one filter is rotated. One filter is rotated. One filter is rotated. Okay. This filter remain vertical and now this filter is rotated. Sketch a graph to show how the intensity of light measured at the screen varies as the filter number 2 or the second filter is rotated from 0 degree to 90 degree. From 0 degree to 90 degree. So consider it is 30 degree, this is 60 degree, consider this is 90 degree. When the light is incident on the filter number 1, you are given its intensity is 1 watt per meter square. But when light passes through the filter number 1, then I think its intensity reduced to 150, sorry, 50%. When light passes through a filter, then obviously one component is absorbed, other component is passing. So intensity reduced to one half. And then second filter is rotated. Now the second filter is rotated. One of the filter is rotated. There are two filters, one of them is rotated. So when the second filter is rotated, then obviously intensity reduce, and finally becomes 90 degree. When the angle is at 90 degree, when the angle is at 90 degree, then obviously intensity will be zero. Intensity will be zero. So I think my graph is better. And now this is another theory. The theory is the second way to polarize light with is reflection from boundary. It means in your course there are two types of polarization. The first part we have completed, in which light is incident on a polarizing filter. And the second way is consider this is a glass block. Consider this is a glass block, and when light is incident on the glass block on the boundary, then some part of the light is reflected, and the some part of the light wave is refracted. Okay, this is refracted, and this is reflected. This is unpolarized light. This is unpolarized light. Then according to this diagram, try to understand when this symbol represent the light is totally polarized. Light polarized. Light polarized. And when they are drawing this symbol polarized parallel to the plane of incident. Polarized perpendicular to the plane of incidence. Sir, what does it mean? I am explaining. Consider this is the boundary. This is the boundary. Boundary means this is the plane of incidence. This is the plane of incidence. And when the light is reflected, then the reflected light is polarized. And this polarized light is perpendicular to the plane of incidence. And this light, this symbol, this symbol means polarized parallel to the plane of incidence. Achha, I am not interested to explain this topic very well. Why? Number one, sir, time is ending. Number two, I haven't find any question on this topic in your past paper. ठीक है ना? या अच्छा, अगर मुझे कोई क्वेश्चन मिलता है, आई विल सर्च, और आपके साथ ईयरली पास पेपर भी हम लोग करेंगे, ठीक है ना? अगर मुझे इसका कोई क्वेश्चन मिलता है, तो ऑब्वियसली आई शुड एक्सप्लेन। ठीक। अच्छा, मैं ये भी बता दूं, एक बहुत पुराना पेपर में मैंने ये वाला सवाल देखा है। बहुत पुराना पेपर, वो भी दिखा दूं मैं आपको, खुद से दिखा दूं। मैं रिकॉर्डिंग बटा बंद कर